here at the conference that you would want to connect with in a one-on-one call afterwards. And this is, this can be some shared interests, some shared, project or vision moving forward, or it can be just a call to sort of reflect on what we learned in this conference and, how that's maybe relevant for us, how, right, like if it's, a couple weeks after the conference, like what stuck with you? I feel like that could be a nice way to integrate learnings and also to already build some of these collaborations and connections that can then allow to keep going. So yeah, just reach out. Maybe over email is best so that if the person doesn't see it right away, but you can also reach out here in chat through direct message to people who are in the room. So
Did you send the emails to everybody? Is there like an email list?
yeah, there's the email that I sent with all the links, and in that there is a directory. Hmm. Yeah, sorry, the emails definitely are a bit packed and there's a lot of stuff there, so it's confusing. Okay, and so with that, um, the questions we just discussed in small groups we'll come back to in big group and we'll keep coming back to, so we'll have more chance to share any insights about that. But yeah, Father Robert, maybe go ahead and introduce Gary.
Yeah, so I have actually never met Gary. This is our first time actually seeing each other, at least online, even though I'm from Madison and my whole family still lives out there. And I actually be
Oh,
back
cool.
there a little bit later this year to see them. But I think his work is extremely relevant to what we're trying to build here because one of the characteristic features of these ancient contemplative traditions that we're trying to see how we kind of bridge that with this complexity science research is thinking about language as a way of achieving cognitive transformation. I think Pierre Hadot has demonstrated this pretty well with ancient philosophy, that they are not, when Plato or Heraclitus write something down, they're not writing it down because they want to like have a piece of information that will enter your mind, so you'll learn some new fact. But they're actually trying to help you go through a process of transforming the way you see the world. And similar way in the Hebrew and Christian spiritual traditions, there's a very strong emphasis on language as yeah as that same way of transforming how you relate to God, how you relate to other people. These and a lot of the prayers are just extremely dense, kind of uses of language, which then creates these problems of translation and how okay if everything is based on these scriptures, how do you even translate those? Um, but yeah, so I think that thinking about language in that way of how that actually structures your cognition is extremely relevant. And so seeing how that, which is the main focus of these older traditions, can be studied with modern tools and integrating that third person experimental perspective with those first person explorations from the history of philosophy, like is a really interesting project for this group. And so seeing what Gary has done from that third person perspective with all of the latest tools that can be leveraged for that, I think is going to be very helpful for us. So, like, Gary, you can introduce whatever else about yourself that you want at the beginning, but I just wanted to at least frame you within our discussion that way.
Great. Yeah, that's really helpful. Thanks, Robert, and thanks, Pavel, for inviting me. So I'm a cognitive scientist. I mostly do experimental work. Of course, in cognitive science, experiments and theory kind of go hand in hand. We're generally the same people. Uh, so I don't know if I can totally live up to here are the latest tools. I'm going to give you a sampling of some fairly straightforward behavioral experiments. I've done stuff in cognitive neuroscience as well. Um, and one tension that that is present in thinking about these big questions, right? How does language augment cognition? How does language change how we interface with the world? Is that there are only sort of certain versions of that those questions that are amenable to being answered in experimental using straightforward experimental methods where we take people. The general methodology I've used is trying to understand that causal link between language and various aspects of cognition and perception by tweaking a little bit something about language, right? Kind of you can think of it as turning a volume knob up or down on language a little bit and see what effect it has. And so the effects might seem in some cases like, well, that's just, a little bit of a change in reaction times or accuracy, but they speak to these larger theoretical issues of, on what theory would this causal link be present? On what alternative would we not expect it? So 3 acts. I'll start by talking about language as a conceptual scheme and point out, although most of my work is not so much comparisons between languages, it's more of language versus something else. It's instructive to look at some differences between languages. Some examples, I'll go through a few experiments for language augments human cognition. And the third part is more out there, connecting it to some of the themes of this conference, and also to the madness in good and bad ways that's happening with AI and large language models, because those are extremely, I think, relevant to both as a stress test of cognitive theories, but also as an interesting stress test of just information. What kinds of information might we be surrounded by that we are not with our minds realizing is there? Okay, so here's an old philosophical question that still has currency in cognitive science and developmental psychology. What comes first, the concept or the word? And the widespread view is that there are things out there in the world. Some of those things are important to us. We care about cognizing them. We care about communicating about them. And so, here are some dogs. You have the concept of dog. And then if it's sufficiently communicatively useful in your culture, probably not you individually, but the community has coined a word that labels the concept. Okay, so this is kind of the default view that linguistic categories are more or less, as Liam Gleitman says, straightforward mappings from a pre-existing conceptual space. Humans invent words that label their concepts. And so on this view, word learning, language learning more generally, is a mapping problem. You have these messages, these concepts in your head, and what language is an interface for that allows you to publicly communicate about them. Okay, now, this view allows for cross-linguistic differences, so it's certainly possible that, in your culture, it's not that important to communicate about students or the concept of blue or yellow, and so you might not have words for these things, but on this view, that doesn't really tell you anything about the underlying concepts that you have. Here is a different way of thinking about words and meanings that comes from more of the tradition that I've been raised in academically, with connectionism, where words are viewed as cues to meaning. So Jeff Ellman, drawing on the work of David Rumelhart, talks about words being thought of as other kinds of sensory inputs. They act directly on mental states. So you can imagine if this is your, this manifold represents your semantic knowledge, that's influenced by, in some cases, maybe some innate or core knowledge, direct experiences, your direct interactions with the world, but also by language. And so this view then leads to a different sorts of questions. So what kinds of cues are words? So how does language warp your conceptual space, your representations, compared to other kinds of inputs? How are they different from non-linguistic cues? And how important is the language part of input to human intelligence, but also to human-like intelligence? So if you want the human-like intelligence, do you need to feed it language? Okay, and so on this view, words don't map onto concepts, they help create them. This does not equate language to thought or thought to language. Rather, it suggests that to some extent, human thinking is language augmented thinking in for typically developing humans. The experiments I'll tell you about focus on categorization, which is a central process in cognition. Quite a bit of cognition is categorization in one way or another. So what is it? It's treating different items as for some purpose equivalent, right? So here are various categories, and you can ask, how do we learn them? How do we represent them? Does it matter if they have a name? And one sort of intuitive perspective that I think is one of the reasons why this view of kind of words as just mapping onto concepts, why that's intuitive and why that remains popular, is that we have a notion that the reason you call something by a certain name is that it has some, there's a chairness to chairs. There's a kind of essence, right? So it's not random that we call all these different, obviously perceptually different chairs by the same name. The reason is that, they have chairness, right? And this is where cross-linguistic comparisons are useful, because if that were the case, we might expect languages around the world to agree on what the reasonable categories are. And in fact, they don't, at least not really. So, if you ask English speakers, why do we use the word open for all of these situations? And this was one of Benjamin Worf's insights. If you ask why, opening a box, opening a hand, opening eyes, drawer, so well, because they're similar. They're all about opening. But in fact, this is only one of many possible schemes, right? And so if you compare the English scheme to another one, like Korean, you find here's a very different way of carving up this space. And so to a Korean speaker, why would you use the same word for these? Well, because there's obviously something that they have in common. And although we as English speakers can appreciate these similarities, they're not habitual in the same way, right? So we don't have to think about, why is it that opening a hand and opening a drawer, we just do it. We copy the patterns learned from our language, and they become entrenched and habitual. Here's another example with carry. So this is actually, interestingly, we can come back to this maybe later. English has many of these so-called light verbs that are really quite abstract, where we have verbs like go and move and carry that are kind of atypical in the scheme of different languages, in that they don't specify move how, carry what, whereas many other languages do. And so you cannot just in general talk about carrying. Okay. Right. So do names matter? Okay, I'll show you one quick experiment that is not that surprising, but it's nice to show experimentally that they matter for communication, maybe in ways that you might not have thought would really make a difference. And then the more interesting question is for cognition. And here, the cognition one is the controversial one, right, where people tend to be skeptical, although the tide has changed since I started this work. But here's at the bottom a review paper from last year, where Fedorenko, Piantosi, and Gibson, they argue that based on neural dissociations, and I have a lot to say about that, but we won't go into that now, language only reflecting then giving rise to the signature of human cognition. Okay, so right, so on the one hand, there's this kind of reflection view. On the other, I mentioned Worf, the classic quote, language as a construction. Okay, and in this quote, it's interesting because Worf is making this claim about this kaleidoscopic flux of impressions it's also kind of echoing William James, has to be organized by our minds. And that bit, everyone's on board with, pretty much, right? We take in cognitive science and developmental psychology, we take a constructive view of learning. You don't just pick these things up, kind of pluck them from our environment. We engage in a process of construction. What's more controversial is the role of language in this process of constructing structure and categories. Okay, so here's a quick study for do lexical differences matter for communication? So this is a cross-linguistic study where we take advantage of difference here in this case between English and Chinese in superordinate terms. Okay, so if you ask English speakers how would you call aspirin, marijuana, cocaine? How would you convey this category to someone else? Many people say, well, drugs, that's a superordinate term. Pests. The ones on the right, though, there's not going to be that much agreement. Everyone can appreciate what these things have in common. They just don't have a conventional term, but in Chinese they do. Okay, and so the task here is very straightforward. We have two people. There's a director who's seeing this 3x3 grid of words and has three of the words highlighted for them. And they have to type in some word that allows, or a phrase that allows another player to click on those same three words and just those same three words. They can't repeat the words, so they can't just list the words that should be clicked on. They don't have to, they're not limited to a single term. But in fact, when there is a conventional term, most people do use it. And the question is, if you're lacking a conventional term in your language, can you still succeed in conveying that category? Okay, here's another one. Right, so this one doesn't have a conventional term in English, but people can say, okay, it enhances food taste. Okay. So what happens? So you look at the accuracy, chance here is quite low, right? So people are doing okay, but they're doing better if they're tasked with conveying a category for which they have a conventional term. And in the paper, we go through all the different strategies people use. People are quite clever. And what's interesting is that despite this cleverness, if you lack this community term, this conventional term in your language, it's going to be harder to align with the other person. Okay, so more difficult to align without a conventional label. And these labels are, of course, not invented by the participants. They're just part of English or part of Chinese. Okay, moving on to cognition. So now this gets interesting. Okay, so makes sense, harder to communicate, but after all, like that's what most people think language is really for. It's communication. But what about just thinking for yourself, where you don't have to communicate except maybe with yourself? And so here is a statement from Steve Levinson that I really like, where he talks about, yes, formally 100 is 10 tens, but there is something more cognitively economic in 100 than 10 tens. It's a chunk, right? Similarly, if you don't have a word like aunt, right, you can describe the relationship precisely in other ways, but that's burdensome and cognitively costly. And so most of those complex concepts are inherited from the language we happen to speak, suggesting here that, yes, you can learn, you can convey all these things, but language is giving you this powerful way of compressing them. Okay, so here he's simply asserting it, but we can test it. So do easier to name things really make for better cognitive chunks? One might think, well, what does it matter? We don't need to communicate to ourselves, right? Do we? So here's the simple task. Here's some colors. The ones on the top are, not surprisingly, easier to name, at least for English speakers. So if you just have a free naming task, you can call these things anything you want. That 85% will converge on these specific words: orange, red, blue, brown. And for these ones, people will not. They can use all kinds of names for them. These are the modal terms. That third one is gray, even though it's obviously not gray, but that's the modal term because there's such a variety of names that people use, right? So there's no trouble in distinguishing the bottom colors. You can appreciate they're different. It's just harder to name them. The task is the following categorization task, where people see these color wheels, and on each trial, they have to drag it into the left bin or the right bin, and then they get feedback telling them if their choice is correct, and then they see the next trial. There's a very simple rule that determines category membership. People are assigned to two conditions. The rule is the same. The logic of the rule is the same. In the high nameability condition, you can see it, right? In both cases, it's just about the presence of a particular feature. In this case, red is category A, brown is category B. Same thing here, except these colors are harder to name. And so presented this way, it's pretty easy to see what the rule is. But if you see these one at a time, it becomes harder. You have to integrate across trials. And so does that matter? Okay, again, there's no trouble in distinguishing these different colors. They're all very different. And the logic is the same. And it matters. It matters a lot. You already start to see this with kids. In kids, you can see that it correlates with their color vocabulary, how well they do on the task. And so one way of thinking about what's happening is that people are, in fact, communicating with themselves. This is a very explicit kind of task. They know that there is some rule, or they guess there's a rule. And they're asking themselves, oh, maybe it's about the purple thing. Maybe it's about the red thing. And then they can confirm or disconfirm it in the next trial. And the idea is that those hypotheses are harder to pose when they're about these harder to name things. Okay. Colors are not special. So here are these tangram shapes. In this orientation, they are relatively nameable, although not nearly as nameable as red and orange. And here we can have a really nice, precise psychophysical control where all the low-level features are the same. You just flip it upside down, and now that's harder to name. And so you compose the same kinds of categories with these harder to name or easier to name shapes, and you replicate the effect. So it's a very robust and easy to demonstrate kind of phenomenon. And so in that experiment, people have learned these names previously. We're not teaching them anything. And they are recruiting them during the task. And so we can ask how far we can push that process. I'm not going to tell you about the work where we teach people labels, so it matters. So you can teach people labels, and then hard to name things become easy to name things, and you get some of those same benefits. But instead, I'll tell you more about effects on lower level processes like visual perception. Again, these ideas are old. So this is Sapir talking about comparatively simple acts of perception. The specific example I think he was giving in this passage is appreciating that a dashed line is different from a solid line. The sort of they might be different in all kinds of other ways, but that certain distinctions are brought into focus by their names. And here's a fun little. This is not really low-level perception, but a fun example of the use of language to ascribe meaning to something that initially seems meaningless. So it's an old, this is I think from the 70s originally. Some of these have gone on to become famous in their own right, these little drawings. Okay, so you can appreciate that, okay, it's not that you can't see what this is, right? You just did some lines, some geometric shapes, maybe a triangle. Um, but you can make it more meaningful with a verbal description. So language here is helping you to construe the shapes as not just an accidental arrangement, but as part of a more meaningful scene. Okay, so these are the so-called droodles. Okay, here's a more compelling case. You may have seen this illusion before. Okay, so if anyone wants to unmute and say do you notice anything unusual about
It's
this
both a
image?
cigar and a rock.
Does anyone see the cigar?
Yeah.
No.
No.
I do. It took me a really long time to see it the first time.
Yes.
I actually had to sleep on it.
Once you said cigar, immediately came up. But for a minute, I thought that I'm seeing a bird or
Yeah.
something.
I also see a
So
bird. Still don't see a cigar.
Where are we looking?
where we're looking, so I'll tell you, and I can also show. But so that rock in the middle is not a rock. It's the tip of a cigar which is coming out of the brick wall. And the gap is
I see
the
it now.
whatever body of the
Yeah.
cigar. So you have this image that has several interpretations. One is better than the other because it makes sense globally of what is otherwise just an arbitrary like gap in bricks, a rock. And so you can, of course, use visual inputs, like I can highlight the cigar for you, and that's very effective. But what's remarkable is you can also use language to shape your attention in a way that allows you to reconstrue the scene. And also, once you see the cigar, it's very hard to go back to unsee it because, right, this is now a deeper attractor. It's a better representation of the scene. Okay, so unlike the sort of duck rabbit type ambiguous things, which they're both good and they keep flipping, right? In cases like this, it will not flip, really. Um, and so you are now, like, language guided you into this attractor state, and you will forever stay there when seeing this image. We have an account of all this in a predictive coding framework, right? Where what language is good at is posing high-level categorical hypotheses, right? Is it red? There's a cigar, right? These are categorical claims, right? And so perception and language are specializing in different things. Perception is for the most part analog, it's high dimensional. Language, the currency of language, are categories. And language, in part because it deals in categories, also allows you, it provides this highly effective way of recombining. It's much easier to recombine categories, right? You have your, colors, you have your shapes, and now you can say, a purple circle, right? A blue square. Okay. And so let me show you an experiment. If that's the right way of thinking about it, we might expect that under the right circumstances, we can actually see this categorical warping of perception by language. And color, again, is a nice domain to look to use because it is a continuous space, but we talk about it categorically. Okay. And so the question is, when you label, when you process a color label, does that promote more categorical perception? There is a somewhat counterintuitive prediction here, which is if you think about imposing these categories on an initially continuous space, the spacing between them represents the ease of discrimination, so representational distance. So you might expect that it should become easier to distinguish things that straddle a category boundary. It might become slightly harder to distinguish things that are already, pretty typical examples of these terms. But there's also a prediction that in spreading apart this category, it becomes actually easier to distinguish things that are kind of in the middle of the category. And this is a demonstrated phenomenon in categorization where if you kind of if you have to represent a certain category boundary and things that vary along some dimension, to do it, you actually have to kind of spread the category apart, right? So if you are, for example, learning the distinction between cars and trucks, and it's part of that, well, they differ in their aspect ratios. Well, that's going to make it easier to detect, also to discriminate between different kinds of cars and different kinds of trucks insofar as they differ in aspect ratios. So we have a straightforward discrimination task. People see 4 colors and they just have to respond which of those 4 is different from the others. It's not speeded. So we're just looking at accuracy, and we can probe this at different points in color space based on where they say their, let's say, blue-red boundary is, or green-blue boundary is. And so, oops. On each trial, they see these 4 colors. This is exaggerated. The actual colors are harder to distinguish. And on some trials, they actually hear a word. So in this case, green. So green applies to all of them, but it applies more to one of those than others. So the odd one out, the color of the odd one out is the thing being named. And on other trials, they just hear a bit of noise. And so what you see is when you hear a color term, it becomes much easier to distinguish between, so if you hear green, between greens and blues, typical greens also from less typical greens, and it becomes slightly harder to distinguish like a really typical green from a slightly less typical green. So that's not a reliable difference, but the interaction is obviously. Interestingly, if you try to convey what might seem to be the same information, but non-linguistically. So we'll show people an exact preview of the color. That has no effect, right? So this preview is not categorical in that, well, that's a specific color. And people could label it as green and kind of think the word green, and maybe they are, but that's not actually the same as explicitly presenting the label green. All right. And so moving on to part 3 and connecting some of these ideas to, so over the last few years, my lab, we've been doing various work on large language models, which are, from my perspective, interesting several ways. One is that they provide this astonishing existence proof of just how much is learnable from language. Right? So people obviously learn many things from language and many, many things from the world itself. Text-only LLMs, right, don't have access to the world in the same way. It's being completely mediated through language. And so finding that all of these kind of cognitive abilities seem to be, not necessarily in human-like ways, but seem to be instantiated in a system, general purpose neural network, trained on language, is surprising and interesting, right? So if you have this view that language only reflects rather than gives rise to signature sophistication of human cognition, you'd be surprised, right, that say all recent progress in creating domain general cognitive systems, not domain general in some absolute sense, but relative to everything that's come before, all recent progress has come from training general purpose neural networks on natural language. And so that is not that controversial a statement, but what you make of it you can vary, right? So you might say, well, Yeah, I mean, that's because there's a lot of language laying around, and that's just practically the easiest way to train these models. And if we had other big sources of data, that would work better. It's just, it was impractical. And so this is sort of what Jan LeCun kind of implies here, that language is limited in all of these ways. It's serial, it's slow, it's low bandwidth. What we care about are thoughts. And so if we could train on thoughts instead, right, that would be much better. And comparing it with this, Worfian perspective, maybe that's actually not quite right. Right? That yes, language is imperfect and incomplete and low bandwidth. But maybe that's kind of natural language. That's kind of the best system we have for constructing things and aligning, right? And so there's a book that just came out by Blaise Aguirre-Arcas, super interesting guy, that I highly recommend. And he, I think, frames the kind of the surprising rise of large language models in, to me, the right way, and helps to clarify some of these misunderstandings. So language prediction is, in his terms, AI complete, right? So if you're a system that can successfully predict the next word across a wide range of contexts, you have to be able to do, in principle, you should be able to do anything. Okay? Right? So if you can pose your problem through a keyboard, right, you can pose it, including, there are various ways of taking visual inputs and converting them into text. You can pose it to a language prediction machine. And if it has the right kind of knowledge, the right kinds of representations, it should be able to answer it. And so what looks like a single narrow language task, predicting the next word, turns out to contain all tasks, or at least all tasks that can be done at a keyboard. And so the power of prediction to learn language has been understood for quite a while, for many decades now. But people didn't, I think it's fair to say, both in computer science and cognitive science, they didn't think it would kind of go all the way. So, right, so hope otherwise seemed as naive as the idea that you could reach the moon by climbing a tall enough tree. It seemed clear enough that a real AI ought to be able to do next word prediction well, just as we can. Nobody expected that simply training a really good next word predictor would actually produce a real AI. And it takes more than that, but what's remarkable is that, so for example, models trained only through self-supervision are not actually that useful, but they provide a base representation that you can then very effectively fine-tune for specific tasks. But you need that first, at least as of now, this first stage of pre-training, right? And so what is it about language training that seems to work so well? So one answer is already implied in Blaise's point, is that you can express in language lots and lots of domains. So you can have a general purpose neural network system whose task is to predict pixels, fill in pixels in images. And that is a really effective way of training a vision model. But you can't have a conversation with it. It doesn't develop all sorts of downstream, right, theory of mind type abilities. It's limited to the visual domain, whereas language can express information across many domains. But there is more to it than that, because how language expresses this information matter. So this is from philosopher Ruth Millikan talking about different ways of recognizing, for example, recognizing rain. And so she writes, falling on English speakers, here's another way it can sound. Hey guys, it's raining. Okay. But there is a really critical difference between the linguistic way of recognizing or conveying raining and these other ways, which is that while every type of rain is different and every experience of being rained on is different, we can both talk about the differences of those experiences at, in detail. You can write a whole paragraph on, precisely how the person felt being caught in the rain, but you can also just say rain. So you can abstract away all those things. And this is a type of highly compressed representation. So language gives you the ability of abstracting away from particulars. And this seems important. Okay, so this is a recent paper also from philosopher, making the claim that natural language makes general inference computationally tractable. So in this view, it's not a coincidence that these advances have come from training models on language specifically at scale. It's also instructive to look at what happens when language and visual information are combined. So here's an image made. This one is made by Gemini, I think. So generate an image of a giant fruit bat made of Legos riding a unicycle. It's fair to say that this is not in the training data, okay? Although bats and Legos and unicycles are. So the model is able to construct a coherent visual scene from this linguistic description. What's remarkable is if we look at, in this case, an open model, so stable diffusion, at the astonishing compression of visual information that has taken place in this model. So stable diffusion is trained on over 2 billion image text pairs. The whole thing, the whole network, you can download it, is 4 gigabytes. So including all the overhead, right? It's basically storing representations of less than 2 bytes per image, from which it can recover all kinds of, interestingly, right, not the exact images it's been trained on. It really can't do that very well. But it can recover all kinds of new combinations on demand, right? So this isn't what's on top is an empirical claim that has not been tested in the way that one would want to test it. But I suspect it's true that certainly in the absence of language, vision models are not compositional or very minimally so. Language is not just a useful interface for getting this stuff out of the model. It's the training with language that I would claim creates or unlocks this compositionality in the first place. So the ability to, like, okay, you want Legos? Let me transform Legos into this other configuration. Okay. And so this gets us to the last part, and this is a bit, I'll do a very brief, linguistic introduction. This is we have something written up on this. We haven't published it yet. I've shared it with various people. The only person who was not impressed is my PhD advisor, Jay McClelland, was like, yeah, okay, cool. But everyone else, including Adele Goldberg, when I showed her this, was impressed. So Adele is best known for her work on construction grammar, recognizing that, you can ask, well, when we learn a language, what is it that we learn? Of course, we learn words. The traditional view is a kind of like you learn words and you learn grammatical rules. Most people don't really, well, I guess a lot of people still believe that, but people who know what's going on don't buy into that anymore. Adele's construction grammar approach is I think, an especially promising direction, right, where there is a continuity of, units of different sizes. So you have morphemes and words, but then you also have these kinds of productive constructions, right? And idioms, right? To jog someone's memory, right? So jog and memory can be filled in by various things, not everything, or the X or the Y, right? So there are many constructions. So part of what you learn when you learn language are these constructions. And so when this is very useful for generalization because you can observe a construction that has maybe words that you don't know or nonsense words, but they're arranged in a familiar construction, right? Like subject, auxiliary, right? Verb in a particular form, right? And you know that, okay, it's some action being done on this subject, whatever it is. Okay? Um, so other people earlier have also picked up on this, right? That there's meaning in the forms, right? So Ingraham wrote, suppose someone were to assert the Gostag distims the Dachas. This became a famous sentence. You don't know what this means. If we assume that it's English, you know that Dachas are distimmed by the Gostag. We know okay, you get the point. And it might seem like, okay, well, yeah, but this just immediately runs into this grounding problem of how can you ever make sense of these things unless are already you already know the system. Okay, so for example, someone back in 2005 or so created a game, an interactive fiction game based on this Gostag distims the Dachas example. Okay, and it's a text only, right? Fiction game. So unlike normal interactive fiction games that are like in a language you understand, here it's this Gostakian that uses English grammar and some English words, but you have to figure out how to communicate, and you don't know what your goal is, what is happening, right? And you just kind of have to figure it out. Okay. This person gives it a 4-star review. Now, it's hard, but people can do this. People can play this game. They generally have to keep notes, keep a kind of a running glossary. It's hard. And you would say, well, the reason they can play the game is that they know English and they can ground the meaning within the game in their knowledge of English. And what is English grounded in? Well, their real experiences in the world. Well, what about a language model that also knows English, but its knowledge of English is not grounded in real experiences of the world in the same way? And so you can deploy, this is what we did here, deploy, I think this is GPT-4o, to play this game. And it doesn't do very well in terms of like beating the game, but after 10 minutes of play or so, it's able to give you definitions of the various words in this game. Okay? And it does so, though we haven't done a proper comparison, it seems to do it much, much more effectively than people. And so this led us to the thing that seems to me still astonishing. So this seems like an impossible task. So here is a passage of English text in which content words have been replaced by nonsense words. And I'm keeping the closed class words, so prepositions, articles, and a few verbs. Okay. Although this one maybe doesn't even have any. So is, okay. Yeah. And so if you ask people to make sense of this, anyone have any like intuitions? Like, what is this? What might this be about?
Kind of feels like it's a description of like a creature or something that we're learning various attributes of some like,
Yeah,
maybe it's like in a natural history of some particular
yeah,
gremlin.
yeah, yeah. So, if you try to make sense of any particular sentence, right, it's not complete nonsense, right? So like when something maybe did a thing that, okay, like you certainly can give, good estimates of like, well, this is some kind of agent, some kind of noun. This is an adjective probably, but to us it doesn't cohere. Um, you can ask an LLM to translate it. Here is the original. Now we have the ground truth because we created this. Okay. It doesn't always work this well. I can give you a more characteristic example. This one, it's just happened to be one of the first ones I've tried, and it works especially well. One person in my lab, a research assistant, his intuition when seeing this was he said it gave him some legalese vibes, right? Which is true, right? But that's still pretty far from being able to recover this. Okay,
This is zero shot.
this is zero shot.
And this text
Yeah.
is probably in the training data, right? The
Okay,
original.
so let me show you the next example. It comes from the supplementary materials of a paper that doesn't come up in a Google search. It might be in the training data. This also works for this. It turns out that it doesn't matter if it's in the training data. That's not what predicts success. But of course, well, unless it's a famous bit of text. Here, we replaced all the nouns with the same string, all the verbs with the same string. That's still enough signal. So there's something left in the constructions. You can think of it as a kind of a high-level meta-construction grammar, right? That is enough, not on its own, right? This sentence is not sensible to the model either, like a single sentence. But when combined, it's enough converging constraints. Okay, so here's an example of a text guaranteed to be never before seen. So this was a Reddit post that I pulled on the a day before I was giving a talk with this example in the Netherlands. Okay, so it was just posted. Okay, and this is a model that doesn't have access to the internet, which I mean shouldn't matter because being able to what are you going to search for, right? And this is also I should probably don't need to point out, right? These are random strings that are constrained to be pronounceable in English, but these are just dynamically generated. So these are not in the training data either, right? So to be able to match it to training data, you would need to abstract over all the nonsense strings. Okay, so this person is asking about Unbite whether it's more like bacon, so you need to cook it, or is it more like prosciutto, smoked? Okay, I've been researching in both English and Dutch, can't seem to find a consistent answer. Okay, in this case, the translation, this is a more typical case where it gets the kind of skeleton correct, but a lot of the details are wrong. Okay? So searching on Google and Wikipedia, can't find a clear answer. Okay, but it's about, they're shopping in a store. Okay, but the details are different. Now watch what happens if we take this one word and fill it back in with I don't know why this is also the same, but fill it in with Netherlands. This is the ground truth. So same thing, except now we add one more constraint where somehow, make sense of this in the context of Netherlands, essentially. And that's enough to basically get the whole thing. The only difference here is pork versus beef. Okay, so I promise that I am not just paying lip service to this, thinking about this stuff over the last 6 months. This is kind of where my thoughts have turned. That you can ask, in what universe could this work? Why should this work at all, right? And it works because things are, in language at least, just profoundly relational. So it's patterns all the way up and all the way down. It's relations. And things don't need to be actually grounded in this kind of classical sense for a system to be able to make sense of it. Right? So of course, if you are blind and you have no visual experiences of something, you cannot pick it out visually, right? But you still have, and we've done some work comparing visual knowledge in sighted and blind people, and it's remarkably similar because blind people have access to other modalities, but also critically language. And so language helps constrain the visual world in ways that allows blind people to make a lot of the same inferences that sighted people do. Okay, and so you can think of this, right, as a kind of fingerprint, right, where the reason you can make sense of it is that even this, very sparse, right, but it's right right when brought together, you would only expect it, right, if certain relations are just right. So, taken apart, if you just take a single sentence, that's not enough of a constraint, right? And it might seem like this would be much more complicated. There's just more stuff to make sense of. But actually, when you start combining these constraints, there are only a few ways of resolving them. And so in some respects, one can say, well, LLM is doing something quite alien, like we can't make sense of this. From another perspective, we do this all the time. This is what perception and cognition are like. It seems trivial that like I can look at this and recognize it, as a coffee thermos, right? But if you think about the actual informational, thing that's happening, I'm taking a set of constraints, set of inputs, right, and resolving them in a way that seems the most likely. And the LLM is doing the same thing with language, in this case, in a superhuman way. Okay, so I'm out of time here, but yeah. So some conclusions.
Great. Well, thank you so much, Gary.
Yeah.
So now I think we can probably, I think if Pavel agrees, do the same as last time, where if people need to take a break, now is a good time, but the rest of us can keep going with some questions and discussion. And we'll plan to resume with Omer's meditation at 9:30, or 9:30 my time, 10:30 Eastern time, which is the standard for this schedule. So in 10 minutes from now.
And just want to say this, I feel like I was just punched in the face by these results. Just, I feel kind of floored.
It's wild, right?
Yeah. Ooh, very, embodied experience.
Are you taking any questions?
Yeah.
Yeah.
Okay.
I'm happy to chat.
So is your position that like basically there's really, I mean, given that these models are sufficiently, trained, that like they don't lack any kind of lack or information regarding like their lack of grounding in embodied experience. Like it can all be bootstrapped from language itself.
Yeah, I mean, I'm of course very aware that language, in this case, is produced by people who live in the world and who are embodied. So we're not at the point where these models are existing in the real world and creating language that is training other models. I don't know. I mean, I don't think that's in principle impossible, but that's not the situation, right? So um, the knowledge is coming, the original knowledge, I mean, the input is all human produced in this case. But yes, so you can think of it as an indirect kind of embodiment, right?
Mhm.
So the reason that, for example, congenitally blind people can know so much about the visual world through language is that most language is produced by sighted people. And it's not that people talk about what things look like directly necessarily, it's that the structure of the visual environment leaves imprints on the statistical structure of language that can be these, latent in the language that can be recovered by blind people and by blind language models.
I think Amit has a question.
Hey, Gary. Morning. That was
Yeah,
fun.
I mean,
Yeah. Hey, so if you were to I don't know, say what are the one or two or three or six facets of this like third chunk of your findings on LLMs, or what you think is so astonishing about it, what is surprising? How would you summarize that?
about the LM
Yeah. Yeah, like
building.
this idea of this kind of like unbounded higher order pattern recognition. What is
Yeah.
I'm trying to wrap my head around
So
what is
yeah, so
remarkable.
other people have said this before me, but LLMs seem to be instantiating these fairly general pattern learning machines,
Mhm.
right? That in being exposed to language, you learn not just the structure of language, but you learn to learn. Not
Mhm. Sure.
there are limits to this, of course.
Yep.
Uh,
Right.
and I don't.
Hmm.
I mean, right? The input is human to LLMs, but it's right. We are living in this larger world, and our interests and abilities are constrained by the physics of the real world. So the models are being exposed to the physical constraints of the real world through us, through language. So I don't see the models as kind of, windows into some ultimate reality. But what's so amazing is that there is enough information, right, in
Hmm.
just language at scale that
Yeah.
allow models to learn a representational scheme that affords performance on all these other kinds of downstream tasks. Um, so
Uh-huh.
that
Uh-huh.
is
Uh-huh.
to me
Uh-huh.
the really impressive thing. Now there are
Uh-huh.
other things that were
Uh-huh.
like lower bars, right? Just like the ability to learn language from language itself. Uh, obviously the models show that this is possible, uh,
Yeah.
and
Yeah.
actually a much easier problem than linguists have assumed. But it's not just that, right? So part of what makes language possible in people is that we have this inferential machinery. Language is actually, as LeCun pointed out, it's
Right.
serial, it's low bandwidth, it's very ambiguous, but it's very effective with limits, of course, on communication because we don't just decode the words, we are
Uh-huh.
decoding the mental states given the words. And so the general way of thinking about it is that to be able to use language,
Yeah.
you need an organism with this complex pragmatic inference.
Uh-huh.
And what LLMs are really good at, right?
Yeah.
They're not that great at factual knowledge, as we all know,
Yeah.
but they're really good at pragmatic inference.
Uh-huh.
So in my various interactions with them, there are plenty of times where it's not executing the task correctly,
Yeah.
but almost never at this point is it fundamentally
The
misunderstanding the
operation.
task.
Gary, and do you think, and just to follow up, and this is, I think, what you're doing and the inferences they're probably like 6 pay grades above my capacity. But I have this like, I've been listening to you for the past 20 minutes and been thinking, is this say that LLMs are amazing, or is this actually saying that language is amazing? And I'm actually thinking more it's the latter than the former.
Yeah, yeah. It's really, I mean, I think LLMs are, the transformer architecture is a major breakthrough.
Sure. Yeah, of course, of course, of
It's a real
course.
breakthrough, but right, it's a general purpose learning machine.
Yeah.
Um, right. And so the power here is really in, you know, what it can do with the input, the training, right? But without the training, it's not doing anything without the language input. So yes, it's more of the second.
More of this.
And so, right, transformer networks are not language network. The only thing that makes them language models is that they're trained on language. And it's yeah. So to me, the like important lesson here is
Mhm.
that
Mhm.
um,
Mhm.
the language training is
Mhm.
what ends up producing these kinds of abilities.
Mhm.
And that, of course, raises the question of, we too are language trained,
Precisely.
right, in part, right? And so how
Precisely.
much of,
Mhm.
so you can see the connection to the earlier stuff, how much of
Mhm. Right.
our kind of human abilities are actually coming
From language.
from being
Right.
immersed in the
Right.
linguistic system.
Right.
Yeah,
Fascinating. Gary, thank you.
yeah.
All right, 2 more minutes for maybe one more question.
Great. Yes, maybe Jen, if you want to ask yours.
So hi, I'm absolutely blown away, insane. And I'm thinking about the material we've trained it on, the language that's evolved with us about non-human language. Now, I had a conversation with my AI about my parrots because they make a really strange sound when they're really happy. It's a sort of little purring sound. They're really happy. I'm going to give them something to eat, but they make exactly the same sound when they're cross about something. And I couldn't understand
Mm.
this. So I asked the AI, what's happening? And it shot off on talking about non-duality and the state of mind in the parrot. And I was like, wow, this is fascinating. So I'm just wondering, I mean, really all life is full of language. We've got human language, but there's the language of biology and the language of so many things. And I'm wondering how maybe we can even train the models better to the non-human world of language. I don't know if that I mean, we're already doing it, I suppose, if it's training on all the things we're saying, but I'm just wondering if there are specific kind of models that are taking in non-human language. Just queries.
Yes. So there are some projects that are in animal communication that are, let me just stop sharing that are yeah, training models on recordings of communications of other animals to trying to recover structure from it that in some cases, we